In this video, we're going to solve the fairly complicated polynomial inequality shown. And the first thing we're going to do is get all the terms onto one side, make the other side equal to 0, and that's going to allow us to factor and to do our interval testing. Okay? So that's what we have. Now, right away, we realize we're going to have to use the factor theorem. If we plug a value of -2 in for x, we get a value of 0 in that lengthy fifth degree polynomial. So we're going to do some synthetic division here. Okay? And if you haven't mastered this step yet, this is definitely something that you want to have mastered. Okay, so now we know that that original polynomial inequality is x plus 2 times a fourth degree inequality is greater than 0. So now we look at that fourth degree polynomial inside the bracket, and we wonder if there's any values of x that make it equal 0, and lo and behold, -2 makes that expression equal 0 as well. So we're going to do our synthetic division. This factor theorem is really useful. There. And so now we've got x plus 2 quantity squared times a third degree polynomial. Okay. Now, -2 does not make that expression equal 0, but an x value of 3 does, which means we can do our synthetic division again. And we see that x plus 2 quantity squared times x minus 3 times 10x squared plus 21x minus 49 is greater than 0. And that can be re-expressed as x plus 2 quantity squared times x minus 3 times 5x minus 7 times 2x plus 7 is greater than 0. So now we're going to do our interval testing with that factored expression. Allow me a moment to rewrite it on this screen, and we'll get to work. Okay, we make our number line with our values, our zeros of that expression written from least to greatest. And we test. If we let x be a number less than -7/2, the entire expression on the left-hand side is negative, because we have a negative squared, which is positive, times a negative, times a negative, times a negative. When we multiply those out, that is negative, so it is not greater than 0. When we have a number in between -7 and -2, for x, the x plus 2 quantity squared, even though x plus 2 is negative, x plus 2 quantity squared is positive. The x minus 3 is negative, the 5x minus 7 is negative, but the 2x plus 7 is positive. Now, is a positive times a negative times a negative times a positive greater than 0? Absolutely. When we pick a number in between -2, like let's say 0, the x plus 2 is positive, so squaring it is positive. X minus 3 is negative, 5x minus 7 is negative, but 2x plus 7 is positive. Multiplying those out does give a number greater than 0. When we're in between 7/5 and 3, for instance, an x value of 2 would be a good example. We have a positive number, then we have a positive factor, a negative factor, a positive factor, a negative factor, a positive factor, and a positive factor. Multiplying all that out does not give us a number greater than 0, so we put an x there. And finally, when we let x be a number greater than 0, for instance, a number like 1,000, all of the factors are positive. Multiplying them does give a number greater than 0, so it makes our inequality true. So now we can state our solution set. Now remember, the original inequality had a greater than sign. It did not have an equal sign. Because we're using an inequality that started out as a polynomial inequality and also has no equal sign in its inequality operator, we are not going to include the values of -7 halves, -2, 7/5, or 3 in our solution set. Now, if you want to see why that is, just let x be any one of those numbers. If you let x be any one of those 4 numbers and plug it in for x in the expression above, you end up with the statement 0 greater than 0. Well, that's not true. So that means we're not going to include any of those numbers. So our solution set is the set of all x element of the reals such that -7 halves is less than x is less than -2. -2 is less than x is less than 7/5, and x is greater than 3. And if we want to state that in interval notation, we can say x is in the interval from -7 to -2, in union with the interval -2 to 7/5, in union with the interval from 3 to infinity. Round brackets on all those intervals because they're not actually, those values aren't actually included in the solution set.